Okay, everybody, good evening, and welcome to the final review. It is also the final video I will be posting this school year. Of course, if you're really intent on missing me, you can always, keep track of me and watch further geometry videos later on in life. Again, they are good for two reasons. One, to learn geometry, and two, for that narcoleptic effect. When you just can't sleep, you can always put this on, listen to my voice, and it'll soothe you right to sleep with these boring tomes of geometry. So, let's get going. So, what we're going to do here is we're going to talk through all of this. This is going to be lengthy, probably a couple hours. What I suggest you do is go ahead, try your best, work through the problems themselves. You can go back. There's another video on here just called Final Review. You can check your answers. If you don't know how to do something, even after looking at that, then go ahead, load this one up, fast forward it to where you're having difficulty, and go from there. Listen to that explanation. So hopefully that'll help. So, number one. So number 1 through 4, all of those deal with what is called the segment addition postulate. And that is just breaking a long stick up into two little sticks, and the two little sticks equal the long stick. Now, in the segment addition postulate, as well as the angle addition postulate below, I highly recommend that you do what I just did, and that is write out exactly what adds up to what. So here we know that US is equal to ST plus TU. Now, the reason we do that is so when we start plugging things in, we can keep track of what goes where. Here we're told that US equals 5. We're told that ST equals X plus 5. And we're told that TU equals X plus 8. So what we're going to do is we're just going to use algebra now. We can add those together, 2x plus 13. 5 equals 2x plus 13. We're going to subtract 13 from both sides. We're going to get negative 8 equals 2x. We divide by 2 on both sides. We get x equals negative 4. Now, we are not done yet. So if you do this on the final, don't stop. Keep going. Look at the problem. The problem says find TU. So what we're going to do is we're going to plug negative 4 into that x right there for TU. And we're going to get TU equals 4. And that looks right. Let's go over, plug negative 4 into ST, and we get 1. Does 4 plus 1 equal 5? Sure does, so we're good to go. So, I know we're going a little bit out of order, but let's look at 3. So again, we have UV plus VW equals UW. Okay, again, why do I write those down? So then when I go ahead and plug everything in, I make sure I have it in the right order. So now we have 2x plus 20 plus 2 equals x plus 1. Or x plus 15, rather. So we're going to combine like terms, sorry about that. And we're going to get 2x plus 22 equals x plus 15. We're going to subtract x from both sides, and we're going to get x equals negative 7. We subtracted x and 22 from both sides. So now we know that x equals negative 7. We're asked to find uv. uv equals 2x plus 20. We're going to plug in negative 7 for x. So we get 2 times negative 7. That's 14 plus 20. Whoa. Let's go back a little bit. So we have negative 14 plus 20, so we have UV equals 6. So what we can do now, so we have 6 plus 2 is 8, so we should be able to plug that negative 7 in down below and get 8. Negative 7 plus 15 is 8, so we know we did it correctly. Moving over and looking at number 4, we have CD plus DE equals CE. Start plugging things in. We get 2x minus 7 plus 2x minus 9 equals 12. We're going to combine like terms. We're going to get 4x minus 16 equals 12. We're going to add 16 to both sides. We get 4x equals 28. We're then going to divide both sides by 4, and we get x equals 7. That's just for you, Zach. We're going to plug 7 back in, and for DE, we'd get 14 minus 9 is 5. Right here. That's where, oh, that was not what I wanted to do. 14 minus 9 is 5. Apparently, I'll get back to that, so give me a second. But apparently, on this one, I did AB plus BC equals AC. That gives me x plus 12 plus x plus 8 equals 10, or 2x plus 20 equals 10. We're going to subtract 20 from both sides, get 2x equals negative 10, divide by 2, and we get x equals negative 5. BC, we're going to go negative 5 plus 8. That gives us 3. If we plugged in that negative 5 on the other side, we'd get negative 5 plus 12, or 7. 7 plus 3 is 10, so we double check it. Now we're going to go back down to number 4. We're going to go 14 minus 9 is 5. Okay, now moving on to number 5. So here we are on 5 through 8. These are the angle addition postulate. Same general idea. The two little angles are going to be the big angle. Again, I highly recommend that you sit there and write out that the two little angles are going to add up to the big angle. So we get JTS plus UTJ equals UTS. Now we know, again, what we're going to do. Yellow and blue make green. See? Easy peasy. So what we're going to do is we're going to sit there and we're going to go, well, JTS we're given as 16x minus 7. We're going to add that to UTJ, which was 11x minus 2. And that's going to give us UTS, or 180. So now we just add everything up. We're going to go 27x minus 9. Woo! 27x minus 9 equals 180. We're going to add 9 to both sides. 27x equals 189. Divide by 27, and we're going to get x equals 7. Again, just for you, Zach. So now what we're going to do is we're going to take that 7, we're going to plug it back in. Because we're asked to find JTS. We know that JTS equals 16x minus 7. We're going to plug that 7 back in, so we get JTS equals 16 times 7 minus 7. That gives us 112 minus 7, or 105. So JTS is 105 degrees. So on this next one, number 6. Now a lot of people come up to me and say they can't get it. And most everybody, when they're sitting there and having difficulty with this, they're putting ABT plus ABC equals TBC. In other words, they're having both of those variable expressions add up to 110. Now the reason you're doing this is because back on 5, you had the two variable expressions equal 180, so you're kind of looking for that parity right there. So what you want to do here, though, is write out ABT plus TBC equals ABC. And then you can just go ahead and plug everything in. TBC is 110. ABT is x plus 12. And ABC, 12x minus 10. So it's going to give us, we're going to add everything up, and we get x plus 122 equals 12x minus 10. And subtract x from both sides, we get 122 equals 11x minus 10. Add 10 to both sides, we get 11x equals 132, which means that x equals 12. Are we done yet? Not quite. We are asked to find ABT. So I'm going back up to the top of the page now. ABT equals x plus 12. Plug my 12 back in there. I get ABT equals 24. I know this is jostled. I know there's a lot of writing on one page. Like I said, focus just on what we're doing per problem, and that should help. So, onward. Looks like we're doing number 8. We have NMU plus UML equals NML. Let me go back a little bit and I'll erase that bottom part. Okay. Okay, so NMU, we're given 79x minus 1. UML, we're given 79x plus 1. And NML, we're given 158. Use our algebra there, and we get x equals 1. So then what we want to do, sorry for the skip, what we want to do is plug that 1 back in. We're looking at UML. UML is 79x plus 1. So we get 80, because x is 1. So now I'm going to rewind really quick and talk you guys through number 7. So number 7 is when I write out kind of the application of the, give me a second, of the angle addition property. I get RST, that's the large outside angle. That is going to equal the sum of RSB plus BST. And then I can go and I go RST, okay, I'm told that's 159. RSB, I'm told is 39 plus x. And BST is x plus 132. 159 equals 2x plus 171. Subtract 171 from both sides. And I get 2x equals 12. Divide both sides by 2, and I get x equals negative 6. It was negative 12. So I'm looking for RSB, that was 39 plus x. So I go 39 plus x, plug in my negative 6, and I get RSB equals 33 degrees. Let's move on to number 9. 9 through 12 are all in y equals mx plus b format. That is y equals the slope times x plus b being the y-intercept. So we're asked to find on all of these two things the slope of the lines parallel and perpendicular to the given line. Well, when we're talking about parallel and perpendicular, we're talking about the relationship that the slopes of the two lines have together. So what we want to do is we want to find our slope of our line. We get negative 2/3. Now we know that all parallel lines have identical slopes, so we say the slope of parallel lines, that's what I just wrote, m with a little symbol for parallel, is also going to be negative 2/3. Why? Because slope of parallel lines are identical. Slope of perpendicular lines, that's what the little upside down T thing I just wrote means, are going to be the opposite reciprocal, or 3/2. To get the opposite reciprocal, you take the fraction, flip it upside down, change the sign. Slope of number 10 is going to be, so that's that m we're looking at, 5/4. So the slope of any parallel line, also 5/4. Slope of any perpendicular line, negative 4/5. So apparently I skipped 11 and 12, and that's okay. Just use 9 and 10 as your guide. Same thing, take the slope. Parallel is the same, perpendicular, opposite reciprocal. So here we need to find measure of the angle indicated. So we're looking for angle G, that's 12x plus 4. Now, both of these require the use of what is called the The exterior angle theorem. What that says is that all triangles have to add up to, the interior angles add up to 180. So if we have an exterior angle, then we know that the outside angle equals the sum of the two interior angles. So here we're going to say that NFG equals G plus H. So that angle right there, that exterior angle, is going to equal the sum of the two inside. Now we're going to look over, and this kind of jumps back and forth. This is just from kind of how it was done in class, so I apologize for that. So looking over at 14, that 11x minus 11 is going to equal 6x minus 6 plus 50. So that exterior angle equals the sum of the two remote interior angles. So ZRS equals S plus T. So we go subtract 6x from both sides. So we get 5x minus 11 equals 44. We got the 44 by going 50 minus 6. We're going to add 11 to both sides, so we get 5x equals 55. We're going to divide by 5, and we get x equals 11. Okay, now we'll go back over and solve the rest of that in just a second. Let's head back over to number 13. 13, we get 80 equals 12x. Apparently we're going to do S right now. 66, or 6 times 11 minus 6, 66 minus 6. So the measure of angle S equals 60. Now back to 13. 80 equals 12x plus 4 plus 14x minus 2. So 80 is going to equal 26x. We add 14 and 12x plus 2 plus 4, or plus 2. We got the 2 because we have a plus 4 and a minus 2. We're going to subtract 2 from both sides, and we get 78 equals 26x. We're going to divide both sides by 26, and we get x equals 3. Now we're looking for g. G is 12x plus 4. See, right there, g is 12x plus 4. So we're going to go, and we know that x equals 3, so we're going to go 12 times 3 plus 4 equals 36 plus 4, or 40. Okay, so now we're going to move on to congruent triangles, 15 and 16. So here we're looking, the top one, 15. We see that we're told that two angles are the same. So what we're looking at is whether or not these triangles are congruent. So the first one, we're told that the two sides are this side. Okay, so it's side, side, side. So we have those two sides, and then see how they share that third side. So we have side, side, side. Same general idea for 16. We have two sides. We're being told that all are congruent, and that they share that third side. That's the reflexive property. Now 17 I've marked not congruent. Why? Because while I have all three sides or angles are congruent, I don't have a side. So those three angles tell me that it is similar, but they don't tell me that it's congruent. So all the sides will be proportional, but I have no information telling me that they're the same. Therefore, I'm going to put not congruent. Could be congruent, I just don't have the necessary information. Number 18, side angle side. Because what we're looking at is we have this side right here and that side right there. See those two marks? That means they're the same. We then have that middle one right there, reflexive property. And then we have the two angles. Now those two angles, I know the arcs are a little bit different, but that one arc on each means that they're the same measure. So we have two sides which are congruent, and then the included angle. So that gives us side angle side. Alrighty, so these are exploring isosceles triangles and interlocking isosceles triangles. These are tough, so pay attention. If it starts getting confusing, go back and watch it again. Because if I just sat there and jumped to the end of this, it looks like a hot mess, and we don't want that. So we are looking for the value of x. Now in each one of these, you're given the measure of an angle. So here we have angle 2 for 19 equals negative 10 plus 6x, which means that we need to solve first for the measure of angle 2, plug that back into our equation, and then we can solve for x. So how are we going to do this? We look at that 56 right there, and so let's look at, it's an isosceles triangle. So we know that those two angles right there are going to be congruent. Because in an isosceles triangle, the two base angles which are opposite from the same sides, or the congruent sides, are also congruent. We also know that those two angles are going to be congruent. Why? Because they're vertical angles. So that means all three of those angles with the red dots are congruent. Now up top we have another isosceles triangle, which means that the base angles are also congruent. So now we have all four of those base angles we've proven to be the same. So on the top triangle, if two reds and a 56 make 180, then on the bottom triangle, two reds and a 56 also have to equal 180. So when we're solving for the measure of angle 2, we know that 2 plus angle 2 plus angle 2 plus 56 equals 180. So we can go 2 times the measure of angle 2 plus 56 equals 180. So that gives us 2 times the measure of angle 2. We're going to subtract 56 from both sides, equals 124. We then divide by 2, and we get the measure of angle 2 equals 62. So what do we do now? We go back and we plug that in for the equation where it says 19 measure of angle 2 equals negative 10 plus 6x. We have negative 10 plus 6x equals 62. We're going to add 10 to both sides, and we get 6x equals 72, 62 plus 10. We divide by 6, and we get x equals 12. Again, if that didn't make sense, go back, check it again. We know that all four of those are angle 2. This is just a different way of looking at it. So we know that 2 plus 2 plus, and when I'm talking about 2, I'm not talking about like the number 2, I'm talking about angle 2. Angle 2 plus 56 equals 180, and that's how we got that 56 down there, which means that 2 times the measure of angle 2 plus 56 equals 180, and then that's kind of where we started. So onward and upward. Now look here, in number 20, 2 is an outside angle. Now if we remember going back to 17 and 18, we know that the measure of an exterior, actually we'll have to go up a little bit further, but we know that, I think it's 13 and 14, we know that the measure of an exterior angle is equal to the two remote interior angles. So we know that 2 is going to equal that angle plus that angle. So we know on the left-hand side is an isosceles triangle. So if the bottom left angle is 71, bottom right angle is 71. We know that all three of those angles in that left-hand triangle need to add up to 180. So you go 180 minus 142, which is 71 plus 71, and we get 38. We know that those top two angles are complementary. We know that because of the little right angle symbol right there. So we go 90 minus 38, and we get 52. Now we look at that right-hand triangle. We see that it is a or an isosceles triangle. So we know that that other base is also 52. So now we're in a position to actually solve for the measure of angle 2. We know that the measure of angle 2 is an exterior angle is equal to the sum of the remote interior angles. 52 plus 52. That gives us the measure of angle 2 equals 104. We can also solve it by knowing that measure of angle 2 plus 76 is 180. We subtract 76 from both sides, and we get 2 equals 104. Again, angle 2 equals 104. So now we're in a position to plug 104 in for measure of angle 2. 104 equals x plus 114. We subtract 114 from both sides. We get x equals negative 10. More of the same for 21 and 22. So 21, we're going to start with those two base angles being equal to each other. Why? Because it's an isosceles triangle. So if I call both of those angles y, then I know that 2y plus 80 equals 180. Subtract 80 from both sides, I get 2y equals 100, or y equals 50. If those two equal 50, then those two equal 50. We know that 2 plus the measure of angle 2 plus 50 is going to equal 180. So we subtract 50 from both sides. We get the measure of angle 2 equals 130. We then plug 130 into that equation right there. And we get 130 equals x plus 137. We're going to subtract 137 from both sides and get x equals negative 7. Again, if that doesn't make sense, go back, rewatch them. If it still doesn't make sense, ask me in class. Okay, so 22. We're going to look down at that 113 angle, and we're seeing that it is going to be supplementary to that interior angle right there, which is 67. We know that this is an isosceles triangle, so if that one right next to the 113 is 67, that one down at the bottom also equals 167. Showing you exactly how I got that. So if we know that one of the green angles is 67, we know both of the green angles are 67. We know the two green angles plus that one on the bottom of the line up top have to equal 180. So we know that if we call that angle y, we know that y plus 2 times 67 equals 180. Y plus 134 equals 180. So that angle right there is going to equal 46. We know that angle and the angle right above it are complementary, meaning they add up to 90 degrees. So that's going to be 90 minus 46, or 44 degrees. Okay, so now we know those other two angles right there, let's call it z. So we know that 44 plus 2z equals 180. We're going to subtract 44 from both sides. So we get 2 times z equals 136. 136 divided by 2, and we get those angles are each 68 degrees. So if that's 68, then we know that angle 2 plus 68 equals 180. Subtract 68 from both sides, and we finally get the measure of angle 2 equals 112. Okay, almost there. So then we're going to go 112 equals x plus 119. We're going to subtract 119 from both sides, and we get x equals negative 7. I know that's a long problem, but stick with it. Use your logic. Deduce your way through it. If one thing's got to be true, the next thing's got to be true. The next thing's got to be true. And just push through it that way. Okay, slight reprieve into something a little bit earlier. Here we are, we're talking about the mid-segment theorem. Mid-segment theorem says that if you have if you connect the midpoint of two sides of a triangle, that mid-segment, see how connecting the midpoint gives you a mid-segment? Cool, huh? That mid-segment is going to be parallel to the third side and half the length, which means 2 times the little side equals the big side. We then use our algebra. Make sure you distribute that 2 to both of them. We get 2x plus 26. We're going to subtract x from both sides. We get x plus 26 equals 20. We're going to subtract 26 from both sides, and we get x equals negative 6. Now, for some reason, I started on the other one before plugging x back in to CD. And I get 13 minus 6, or CD or DC, equals 7. Now, if I double that, the top one should be 14. I go 20 minus 6, I get 14. That means I did it right. Back over to 24. 2 times x is 2x, plus 2 times 19, or 38, equals x plus 26. Subtract x from both sides. Subtract 38 from both sides, we get x equals negative 12. Again, I go back, I plug in negative 12 to both of them, and I get CD equals 7. And I get IK being 14. Again, those match up, so we're good to go. I think I skipped, hold on just a second. Sorry about that. 25 was a little bit out of order. Had to go find it. So, again, what we're doing here is, apparently we're going to start with 26 and then go back to 25. So the x plus 1, that's the long one. It equals 2 times the small one, so 2 times x minus 5. We then want to go ahead and distribute that 2. When we do so, 2 times x is 2x. 2 times negative 5 gives us negative 10. So we're going to add 10 to both sides, and we get x plus 11 equals 2x. We're going to subtract x from both sides, and we get 11 equals x. Are we done? Not yet. Remember, the problem is asking us to find xz. Xz is the long side. So plug in an 11 there. 11 plus 1, 12. Over on 25, we know that the short one, x minus 8, is half the length of the long one. So 2 times the short one equals the long one. We're then going to sit there, distribute that 2. We get 2x minus 16 equals x minus 6. We're going to subtract x from both sides. We get x minus 16 equals negative 6. We're going to add 16 to both sides, and we get x equals 10. We're being asked to find DC. See, I even circle it there. We're going to go back, plug it in right there. DC equals x minus 8, or 10 minus 8, or 2. So if we double that, we should get 4 for xz. 10 minus 6, that's 4. Cool. So let's move on to number 27. Okay, 27 and 28 are long, so stick with me. Listen, you may have to watch it a couple times. So, if 3x plus 3 is our line, then we know that that means that the y-intercept is 3. So we have a point at 0, 3. We know the slope is negative 3. So we go down 3 over 1, rise over 1. And that gives us a point of, 1, 0. So what we're going to do then is connect those 2 points, and that's our line. So that's the first part. We now need to write the equation of the line perpendicular to the given line, which goes through the point 3, negative 2. So what we're going to do is we're going to pick 3, negative 2, use our slope, which is going to be 1/3. That's the opposite reciprocal of negative 3. We see that it crosses the y-intercept at negative 3, so we get y equals 1/3 x minus 3. We then want to find the point of intersection. This is the tough part. So those are our 2 lines, so we're going to use substitution. They're already solved for y. And we're going to say that when those 2 intersect, their y's are the same. So negative 3x plus 3 equals 1/3 x minus 3. I'm going to start off now. I want to solve for x. So I'm going to add 3 to both sides, combining like terms. So I get negative 3x plus 6 equals 1/3 x. I am now going to add 3x to both sides after I erase that purple line a little bit. I'm going to add 3x to both sides, and I'm going to get 6 equals 10/3 x. We went over this in class on how you add fractions. If you're still unsure about it, come see me. I'll talk you through it. To get rid of a fraction, we multiply by the reciprocal. So 10/3 times 3/10, that would give us 30/30, or 1. That's why they cancel out. Then we're going to go 6 times 3/10. That is 6/1. So we get 18/10 equals x. 18/10 reduces to 9/5. So now what you got to do? You got to go back. You got to take that x, that 9/5. You got to plug it in to your other equation. So we have y equals 1/3 x minus 3. We're going to plug 1/5 x in there. 9 times 1 is 9. 5 times 3 is 15. That reduces to 3/5. 3/5 minus 3 gives us negative 12/5. So our point of intersection right there is 9/5 negative 12/5. Take a deep breath. Hit pause if you need to. Damp your head with a do-rag from all that sweat you're collecting. And let's move on to 28. So right there, what I did was, so my line is y equals 1/3 x minus 4. That's the red line. Go down 4, 0, negative 4. That's my y-intercept. My slope is 1/3, up 1/3. That's how I get that second green dot. Okay, so that's my line. That's part 1. Part 2, perpendicular line going through 3, negative 2. So I put down my line 3 negative, or my point 3, negative 2. I then go ahead and plug in, I know my slope is going to be the opposite reciprocal of 1/3, or negative 3. That's negative 3/1. So we can either go down 3/1, or we can go up 3, back 1. When we do that, we connect the dots and we get that line. Now, I can go up 3/1 twice more and realize that my y-intercept is at 7. So I could write y equals negative 3x plus 7. But I'm already given the point and the slope, so I can actually plug in 3, negative 2, and my slope of negative 3 into the point slope format. And that's what it would look like. Y plus 2 equals negative 3x minus 3. So what I'm going to do here is I'm going to distribute that negative 3. I get negative 3x plus 9. Negative 3 times negative 3 is plus 9. I'm going to subtract 2 from both sides. And I get y equals negative 3x plus 7. So that's the equation of the line. Still need to find that point of intersection. So we're going to repeat what we just did. We're going to go y equals negative 3x plus 7 and y equals 1/3 x minus 4. We're going to set those equal to each other. So we have 1/3 x minus 4 equals 3x plus 7. We're going to start off by adding 4 to both sides, combining like terms. So we're going to get 1. So we get 1/3 x equals 3x plus 11. We're now going to add 3x to both sides. Again, 3x turns into 9/3. So we get 10/3 x equals 11. We're going to multiply both sides again by the reciprocal. That's 3/10. And that is going to give us x equals 33/10. Almost there. Go take that. That's 3.3. So we're going to go back. We're going to plug that into y equals 1/3 x minus 4. Now instead of x, we're going to write that 33/10 minus 4. Now that 3 and that 33 reduce. 33 is 3 times 11. So we end up with y equals 11 over 10. And then we're going to write 4 in terms of 10. So we're going to subtract 40 over 10. Again, you should know how to do that. If you have no clue how I got 40 over 10, come see me. So we get y equals negative 29 over 10, or negative 2.9. So if we look at that point of intersection, we get 3.3, negative 2.9, and that looks pretty accurate. I'm going to keep it as a fraction and write negative 33 over 29 over 10. Okay, good job, everybody. So all of these are pretty similar. So I'm actually going to kind of speed through these. Then write the name of each polygon. So what we're going to do is we're going to go kind of haywire with these, apparently. So number 30, heptagon, sum of the interior angles, we're going to go n minus 2 times 180. That's 7 minus 2 times 180, 5 times 180, or 900. So the sum of the interior angles of a heptagon is 900. The value of each individual angle we get by going n minus 2 over 180 times 180, over n. So that's the total number of the sum of all of the angles, and then we divide it by the number of angles. So in this case, that would be 5. So we go 900 over 7, not 5, 7. And we get 128.6. Then to get the exterior angle, we go 360 divided by 7, or 51.4. That over there is a decagon. So the sum of angles is n minus 2 times 180, where n is the number of sides. So to find the sum of the interior angles, we go 10 minus 2 times 180, 8 times 180, or 1,440. To find the measure of each individual angle, we go n minus 2 times 180 divided by n. Again, we take the total sum of all the angles divided by the number of angles. So we get 1440 over 10, or each angle has a measure of 144. The exterior angles, again, 360 divided by the number of sides, or number of angles. Here we have 10, so we have 360 divided by 10, or 36. Which apparently I didn't want to write the 6, so I just put a 3. There's a 6 there. Don't you fret. See? Pretty little red 6. Okay, the next one, quadrilateral. You guys should know this. Interior angles, 360. Each individual angle, 90. Each exterior angle, 90. How do I know it's 90 without there being the little right angle there? Because we're told these are regular polygons. Regular polygon, all 4 sides are the same, all 4 angles are the same. That's a regular quadrilateral. In any regular polygon, all the sides are congruent, all the angles are congruent. Then next door, we got a pentagon, n minus 2 times 180. 5 minus 2 times 180, that's going to give us 3 times 180, or the sum of the interior angles is 540. To get each individual angle, we're going to take 540 divided by 5, we get 108. To get each exterior angle, we get 360 divided by 5, or 7. Moving on, 72, sorry. Moving on, each proportion, pretty straightforward, cross multiply. We get 6m equals 49. Divide by 6. We get m equals 49 over 6. And then we move on to the next problem. So we get 8a when we cross multiply equals 4. A equals 1/2. Okay, so the next 4 all deal with proportional sides. When you have 2 parallel lines in a triangle, then so you have when you have a line going through a triangle that's parallel to one of the sides, it divides the other 2 sides, the ones that it cuts through, into proportionate sides. So what we want to do here is we want to set it up. I like to go, so there, 9 over 12, short side to long side. equals short side to long side. That's proportional right there. We're going to cross multiply. Now notice we could also do it short side to short side equals long side to long side. And there's nothing wrong with that. Notice that when we do that, what we're doing is we're still multiplying 12 by 21 and 9 by 3x plus 7. See how it cross multiplies across the picture as well. 12 times 21 gives us 252 equals 9 times 3x plus 7. Never forget, when you distribute, you got to distribute all the way across. You can't just write 27x plus 7. You've got to go 27x plus 63. So we have 252 equals 27x plus 63. We're going to subtract 63 from both sides, and we get 27x equals 189. Divide both sides by 27. That's fine, Jillian. You can get dog food. And we get x equals 7. That's for you, Zach. 7's all over the place. Okay. So, we are told to solve for x. Check it out. We solved for x. We're done. Move on. 38. Here we come. Okay. So that's top left, bottom left. Top right, bottom right. So when I set this up, let's set it up top left to bottom left equals top right to bottom right. So my proportions are now in top over bottom equals top over bottom. That's going to give me, notice I could also do it top over top equals bottom over bottom. And in the end, I still end up multiplying top left by bottom right, bottom left by top right. See, across the picture. So that gives us 180. So we multiply 15 times 12. Get 180. 9 times 3x minus 4 gives us 26 minus 36. I'm going to add 36 to both sides. We get 216 equals 27x. Divide both sides by 27. We get x equals 8. Okay, moving on to number 39. So, number 39, we go. Now here, got to figure out that that little one right there is 12. Because the entire length of those two segments is 27. We know that one of them is 15, the other one's 12. So we're looking for that mystery side, so we go 12 over 16 equals 15 over x. Which gives us 12x equals 240. Divide by 12. And we get x equals 20. Next up, now notice here the x we're looking for is the total length. So I could do this by going, well, that's x minus 27, and then going like 8 over x minus 27 equals 12 over 27. That's a lot of work. So instead what I'm going to do is I'm going to say that the total length in relation to that long side is the same as the total length there, 20, is to its long side, 12. So we get 20 over 12 equals x over 27. That's going to give us 12x equals 216. Divide both sides by 12. And you get x equals 8. Now if I know that's 8 and that's 27, I get, or 18 rather, not 8. I get that as 45. Hopefully that makes sense. Okay. So let's go find 41. It looks like I skipped 41 and 42. We did those in class, however. So here's 43 and 44. So notice on both of these, you have a triangle inside another triangle. So what I'm going to do here on both of them, I'm going to draw out my triangle, label it up, make sure I have the sides. So that top one is 30, 42, and 36.
How many math problems are
They're over 100, and I'm on 43, honey. So, you know, my daughter is like sitting here. She wants to turn the TV on, and I'm doing this. So, notice that it's got B up top. So then we have 130, 182, and 156. Now, notice that because we have all three sides, that if we have similarity here, it is, and we have an included angle. If we have similarity, it is going to be both side, angle, side, and side, side, side. So what we're going to do here is we're going to set up short to short, medium to medium, long to long. So what I'm saying is, do those three sides, are all three sides locked in there? So we sit there and we're going to plug those into a calculator, and they all equal each other. So we get D. Same general idea for this one. We know that U is up top both. So we have 33, 36, 21. If you don't know how I got those, come see me. 154, 98, and 168. So again, we want to set up the ratios. 36 over 168. 33 over 154, and 21 over 98. Those all add up. 0.214 equals 0.214 equals 0.214. So they're all proportional. The sides are proportional. That means they're similar. And we get C. Again, if you don't understand any of this, go back, rewatch it. Go back, find the other video on it. Ask me. Make sure you understand this before Tuesday or Wednesday. So here we have our good friend, the right angle division corollaries. So the first one we're looking at is right here, and it says that the altitude is the geometric mean of the two segments. So that means hypotenuse segment 1 over the altitude equals altitude over hypotenuse segment 2. So we get x over 48 equals 48 over 64. Cross multiply. We get 64x equals 2304. Divide both sides by 64, and we get x equals 36. Next one over. We get x over 12 equals 12 over 9. That is the second corollary, and that says that the this is still the first corollary, because we're dealing with the hypotenuse segments and the altitude. 9x equals 144. Divided by 9, we get x equals 16. Now these next two are the second corollary, and that says that the leg of a right triangle is the geometric mean between the hypotenuse, or of the hypotenuse, and the hypotenuse segment created by the altitude, which is adjacent to the leg. So the hypotenuse over the leg equals the leg over the hypotenuse segment next to it. So we'd get x, that's the hypotenuse, over 15, that's the leg, equals 15, that's the leg, over the hypotenuse segment next to it. That's 9. 9x equals 225. Divide by 9, we get x equals 25. Over here, we're going to go x over 60, hypotenuse over leg, equals 60 over 36, equals leg over adjacent segment. So we get 3600 equals 36x. Divide, we get x equals 100. Okay, so that brings us to 51. So 51, 52, and 53, we're looking at sine, cosine, and tangent. So we know that these relationships occur in a right triangle. Sine is always opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So here we look at the sine of C is opposite over hypotenuse. What is opposite C? 15. What is the hypotenuse? 25. So the sine of C equals the side opposite, 15, over the hypotenuse, 25. It's going to give us 3 over 5, and that's it. That's all sine is. Regardless of how big or small a triangle was with those angles, in number 51, the ratio of the sides is always going to be constant. And the ratio, that's similarity for you. And so the ratio of those sides of the one opposite, whatever C is, to the hypotenuse of that angle is always going to be 3 over 5. So we look at the cosine of C on number 52. We're looking at adjacent over hypotenuse. So the adjacent one to C is 15. The hypotenuse is 17. Doesn't reduce. So we move on to number 53. We're looking for the tangent of A. Tangent is opposite over adjacent. So the side opposite A is 27. The side adjacent to A is 36. Both are divisible by 9, so we get 3 over 4. And that's it. 54, 55, and 56. So 54, what you're going to do is you're going to take your calculator. You're going to hit tangent 85, enter. And then you're going to write it down to the nearest 10,000th. Repeat that with 55 and 56. And those are your answers. That is just calculator work. So 57 through, I think it's like 62. Those are all special right triangles. If it's a 45-45 triangle, 45-45-90, since they're special right triangles, the sides are always going to be in the ratio of 1-1 radical 2. There we see that opposite our 45 side, we have a 4 radical 2. That means that our scale factor is 4 radical 2. Scale factor for 1, scale factor for all of them. So that means n equals 4 radical 2, and m equals 8. 58 is a 30-60-90 triangle, so the sides are in the ratio of 1 radical 3, 2. The 1 is opposite the 30, the radical 3 is opposite the 60, and the 2 is opposite 90, so the 2 is the hypotenuse. Here, we are given that 3 being opposite the 30. We go, what times 1 equals 3? And the answer is 3. So 3 is our scale factor, which means that the side opposite the 60 is going to be 3 radical 3, and our hypotenuse is 6. I got those backwards right there. Let me change that really quickly. So this is 6. This is 3 radical 3. And all of these, that's times, 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 equals, equals, equals. Number 59. So now what we're going to do is we're going to use those same ratios. So 59, 1 radical 3, 2. That 7 is opposite our 30-degree angle, so it's going to go in the 1 spot. Now we go, what times 1 equals 7? 7. So that is our scale factor, so we write it all the way down on our scale factor. And then we're going to go, square root of 3 times 7 equals 7 radical 3. 7 times 2 is 14. So A is 14, B is 7 radical 3. 60 is a 45-45-90 triangle, so the sides are 1-1 radical 2. We see that here, the 10 is opposite a 45-degree angle, so our scale factor is 10. That's going to give us 10 and 10 radical 2 as our missing variables. Okay, 61 is a little tough because when we set this up, we realize that the 10 is across from our 60, which means our scale factor is that which, when multiplied by radical 3, equals 10. So we go radical 3 times our scale factor equals 10. We divide both sides by radical 3, and we get our scale factor equals 10 over radical 3, which would be great, except it's got that irrational number in the denominator. We do not like irrational numbers in our denominator, so we're going to rationalize our denominator. 10 radical 3 over 3. That's our scale factor. It's not pretty, but we can do it. 1 times 10 radical 3 over 3 equals, well, 1 times anything is itself. So we get 10 radical 3 over 3. 2 times 10 radical 3 over 3 is just simply going to be 20 radical 3 over 3. So n is 10 radical 3 over 3, and m is 20 radical 3 over 3. Okay, we're an hour in. If you've been watching this straight through, take a break, go get some popcorn and soda, and come back after a short matinee and enjoying the rest. Now that you're back, and okay, so for me that was like no time at all, but for you, hopefully you went, freshened up, splashed some water on your face, got ready. Here we launch into hour number 2. So when we're looking at 62, we're finding the measure of the indicated angle. Now this requires us to use our arc sine, arc cosine, and arc tangent, or what we've been referring to it in class, inverse sine, inverse tangent, inverse cosine. So here we still know that all of our ratios are the same. Sine equals opposite over hypotenuse. Cosine equals adjacent over hypotenuse. And tangent equals opposite over adjacent. So we're looking for that angle right there. We know the sine of that angle then is going to equal the opposite side over the hypotenuse. Sine of x equals 46 over 48. If I round that, I get 0.96. 0.9583. It's actually okay, so you guys need to remember that there is a 1-to-1 ratio for now. When you guys do Algebra 2, it'll be a little bit different. There's a 1-to-1 ratio of the angle and the sine. If on your calculator you hit the sine of 30, you're going to get 0.5. And that's because if we went back and looked, we could see that in any 30-degree angle, here, we'll just go back here. Any 30-degree angle, the ratio of the 30-degree angle to the hypotenuse is 1/2. Ratio of 30-degree angle to the hypotenuse, 1/2. Doesn't matter how big or small the triangle is, it's always going to be there. So here, what we can do is we can actually ask our calculator and say, oh, calculator, great all-knowing mathematical tool, what angle has the sine of 0.9583? And to do that, we're going to use the inverse sine function. That's what that sine of -1 means. And this is how we do it. You're going to hit second sine, second dash, that's the number right beneath the 3. And then so it'll say second sine answer. You hit enter. You get x equals 73.4. Went over this in class, made sure everybody could do this on their calculator. So you should know how. 63. So here we have the adjacent side and the hypotenuse. That's cosine. So, ka, toa. Ka. Cosine adjacent over hypotenuse. Cosine of x equals 17 over 22. That's going to be 0.773. X equals the inverse cosine. So so you're going to hit 17 divided by 22 equals second cosine, second dash, equals, and you get your x of 39.4 degrees. 64, 65, more of the same. 64, we have our opposite side and our hypotenuse. That's sine. Sine of x equals 9 over 25. It's going to be 0.36. So x, whoa. Catch up. X equals the inverse sine of 0.36. So 9 divided by 25 equals second sine, second dash, equals 21.1. 17, we have adjacent hypotenuse, so we're doing cosine again. Cosine of x, 17 over 36, or 0.472 bar. X equals the inverse cosine of 0.472 bar. Again, the way we do that, 17 divided by 36 equals second cosine, second dash, equals, or enter, 61.8. So now what we're going to do for 66 is we are going to sit there and we're going to use that same ratio, but instead of using it to find the angle, we're going to use it to find one of the sides. So here we have 62. We know that tangent of 62 then is going to be opposite over adjacent. X over 19. We're going to multiply both sides by 19. 19 tangent 62, because we multiply both sides by 19. Going to plug that into our calculator, and we get 35.7 equals X. Again, if you're rounding a little bit differently than me, you might get a slightly different answer, and that's okay. If you're a couple points off, so if you're at 35.1, 35.3, that's fine. If you get 70, worry, go back, double check your work. 67, 19, and again we have tangent. So we know the tangent of 19, what, because I'm on 67? Yep. Tangent of 19 equals X over 18. We're going to multiply both sides by 18. So we get 18 times the tangent of 19 equals X. You want to go ahead, plug that into your calculator, and you're going to get X equals 6.2. So, we got two more, 68 and 69. Again, we're looking for that missing side. Now, when looking at 68, we've got the opposite. I put cosine, and that's wrong. It's sine. Let me get through this, and then I can go back and erase it. Oh, I recognize my mistake. So sine, because we have opposite over adjacent, or opposite over hypotenuse. So we have the sine of 75 equals X over 15. That's the opposite side and the hypotenuse. We then multiply both sides by 15, plug it into our calculator, and we get X equals 14.5. 73, a little trickier, because we have the tangent of 73, 69 trickier. Tongue-tied a little bit. Tangent of 73 equals 20 over X. We're going to multiply both sides by X, divide by the tangent of 73, and we get X equals tangent of 73 as the denominator, 20 is the numerator. Plug that into our calculator, 20 divided by open parenthesis, tangent 73, close parenthesis, and we get 6.1. If you don't know how to do that, come and see me. We went over this in class, so you should. All 5 of my classes went over this. So each and every one of you paying such diligent attention, all geometry long, should know how to do this. 70. First things we want to do when we have a reflection is we want to draw that line, y equals 2. Now, when we reflect something over a line, we do so by that reflection needs to be perpendicular to the line, and so those are, let me back up a little bit. Those 4 points, V, W, X, Y, are called our pre-image points. When we rotate, or reflect them rather, not rotate, when we reflect them over y equals 2, the resulting points are going to be our image points. So pre-image goes to image. Now, when we reflect them, the line that connects the image and the pre-image is going to be perpendicularly bisected by that line of reflection. So we're going to start with X because X is a little easy, and because when the point is on the line of reflection, its image is itself. Now, we know that y equals 2 is a horizontal line. So anything perpendicular to it is going to be vertical. We know that y, when we do this, that y and y prime need to be equidistant, that is equally far away from the line y equals 2. Y is 2 below the line, so y prime is going to be 2 above the line. V is 1 above the line. V prime is going to be 1 below the line. W is 2 above the line. W prime is going to be 2 below the line. Connect our dots, and that's what that reflection looks like. When we reflect across the x-axis, same idea. V is right there. So what we do is when we're reflecting across the x-axis, we actually just change the value, the y value. And what I mean by that is we switch it from positive to negative or negative to positive. So here U has negative 3, 3 as its value. So if we're going to switch the y value, it's going to go from negative 3, positive 3 to negative 3, negative 3. See how I just switched the value of the y? U prime, right there, baby. T. Now T is 0, negative 1, so we're going to change that to 0, positive 1. That's that. And V, being on the line of reflection, doesn't move. And that is our reflected triangle. 72, reflection across y equals 1. There's our line, y equals 1. A prime is on our line, so we don't move it. C, 1 below the line, goes to 1 above the line, C prime. B, 2 above the line, goes to 2 below the line. B prime, connect the dots, done. 73, reflection across y equals 3. Again, V right there on the line. So V and V prime, same point. W, 2 up, goes to 2 down. X is going to go from 1 underneath the line to 1 above the line. And there's our reflection. Moving on to 74. Reflection across y equals 1. U prime right there. Okay, next we have T. T was 1 below the line, gets reflected to 1 above the line, T prime. S goes from 4 below the line to 4 above the line. V goes from 3 below to 3 above, connect the dots, and that's our reflection. Okay, so now we're on to 75. So we're talking about rotations now. Rotations have slightly different rules. When we look at a rotation, we know that the line connecting, now all these are about the origin. We look at the line connecting the pre-image, the origin or center of rotation, and the image itself. So what we're going to do is we need to draw lines through, and that line connecting the pre-image, the center of rotation, and the image have to match the degrees of the rotation. So here we have a rotation about 180 degrees about. So what we're going to do, so F to the origin to F prime has to equal 180 degrees. So that means it's got to be right there on that line. We're going to go, and it has to be equidistant as well. FO and F prime O have to be the same length. Because the difference from F to the origin is 1. The difference from F prime to the origin also is 1. And it's got to be on that line. So that's our F prime. Now E is a little bit different. We know that E to O to E prime has to equal 180. So it's going to be on that line right there. Now we know that then distance-wise, it's going to be up 1 over 2. We then go up 1 over 2 again. And we get our E prime right there. G prime, same thing. We go up 3, back 3. So then we're going to go up 3, back 3. D prime, we're going to go up 5 over 1 to up 5 over 1. and that is our rotated figure. 76, same idea. G goes from -1, 0 to 1, 0. H, we're going to go up 1, 2, 3, 4 over 1, 2, 3. So we're going to go up again 1, 2, 3, 4 over 1, 2, 3. That's going to be H prime. F, we go up 4 over 1. And there we go. So that rotates 180 degrees about the origin. Skipping 77, we did that in class. And just so you guys know, so you should have that down. You are responsible if you want the full 30 points for this. But it's not going to be on the final. 78. So,
getting so close.
We know that y, so notice y needs to, that y angle needs to be from y to the origin to y prime. Needs to be 180 degrees because y is on the y-axis. Y prime must also be on the y-axis. So, it goes from 2 up to 2 down.
2 all around.
W, that would be a straight line, and we go down 1 over 4. We repeat that to get W prime. X goes from 3, -3, or -3, 3, sorry, to 3, -3. Again, on each one of these, a straight line, 180 degrees, would connect each point to its prime, so each pre-image to its image, and go through the origin. 79. S. Notice how here S goes, if we drew a line from S through the origin, it would go right through there. That line is the only line out there which from S to O to S prime is going to be 180 degrees. So it needs to be on that line. Distance needs to be the same. So we're going to go over 3 up 1, over 3 up 1 to S prime. R prime down to over 1, down to over 1. And again, look at how they connect. 180 degrees right through the middle. Bella, can you let the dogs out, please? Q prime. We're going to go down 1, 2, 3, 4 over 3, down 4 over 3. Again, look, that line that connects them is going to go right through our center of rotation, and it's 180 degrees.
No, we're not.
You can just leave it open for a second, huh? P prime, again, is going to be, because it was right here on the x-axis, that 180 line is going to go right through there. Okay, so moving on to 80. Okay, so 80, we're being asked to figure out what kind of transformation this is and then write the rule. Here it is a reflection because it looks like it's mirrored. So we need to find the line of reflection. Lucky for us, we're given that both F and E are on the same point as E and F prime. So that means that our reflection is over line y equals 1. Skip 81, we did that in class. 82, another reflection. We can tell because the orientation, sorry, I couldn't think of the word. The orientation is different. So we're looking for that line which is going to be the perpendicular bisector of each line containing the points. So if we were to sit there and draw this line connecting L and L prime, we notice it's a straight vertical line, which means that the line of reflection's got to be 90 degrees to that, or a horizontal line. We also see that there is 1, 2, 3, 4 spaces in between, which means to get that line, we've got to go 2 spaces. Because again, the distance from L to the line of reflection and the distance from L prime to the line of reflection have to be the same. So we are reflecting over the line y equals -3. 83 is a translation. It's that slide. It's kind of like moving a brick around on the ground. So we count up and over. And it is x, just so you guys know, we did this in class, but it is, I don't know why I x'd it out. It is x plus 2, because we moved 2 this way. And then 4 up. So x plus 2, y plus 4. 84 would be a rotation of 180 degrees. Now notice we could rotate 180 degrees, or we could also reflect it over the line y equals -x. Remember, when we reflect over the line y equals -x, we take the point, so here is, let's pick S because it'll work better. So we know that S equals 3, 2. When we reflect over the line y equals -x, we switch both the positions and the positive negative value of these. So S prime is going to go from 3, 2. It's going to go through the process of switching the positions, and then we're going to switch the plus minus values. So we get -2, -3, and hey, check it out, that's where S prime is. So, just so you guys know out there, rotating 180 degrees about the origin, same exact thing as reflecting over the line y equals -x. Neato, huh? Okay, 85. Home stretch, people. So the area of any parallelogram is base times height. Now the height doesn't mean, just so you guys know, we're not talking about this right here. It's not length, it's not side times side. The height is from this point right here, that's the top, down to the line containing the other side at 90 degrees. So if this were the ground right here, and Andy Angle sitting up there thinking about being a fool and jumping off and see if he could impress his friends with surviving that 3.9-inch fall. Now to you and me, 3.9 inches isn't very big. But look at Andy. He's got to be what, like 1.5 inches tall? So for him, it's like jumping, 18 feet. Because in stick figure line, Andy's pretty tall. Anyway. So area, base times height. Base is 9.2. Height is 3.9. Plug that into our calculator. We get 35.88 inches squared. For number 86. The area of a trapezoid is 1/2 times base 1 times base 2 times the height. Now the bases we're talking about here, those are parallel lines. Now, it is still a quadrilateral, as are the parallelograms, but here it only has one set of parallel lines. The reason that base times height works on any parallelogram is because it has two sets of parallel lines. Here, one set of parallel lines, slightly different equation. But this is B1, this is B2, and this is my height. We go ahead and plug those in. 1/2, 2.9 plus 7.9 times 7.4. 1/2 of 10.8 times 7.4. It's going to be 39.96. Area of a triangle, 1/2 base times height. We got our base there and our height. So we have 4.7 times 8 divided by 2. It's going to give us 18.8. All of these are in units squared. So 85 would be inches squared. 86 would be feet squared. 87 would be kilometers squared. 88 would be base times height, 11.5 times 8. This is in miles, so we get 92 miles squared. 89, we're looking at the exact same formula as 85, B1 plus B2, divided by 2 times H. Again, B1, B2, H. Bella, can you close the door, please, hon? So we get 5.3 plus 11.9 divided by 2 times the height, or 8 centimeters. We have 68.8 centimeters squared. So, area of regular polygons, everybody's favorite. So remember, the area of a regular polygon, 1/2 the apothem times the perimeter. Now, they're regular polygons, which means all the sides are the same. So we're looking at 90. It is a triangle. That means there are 3 sides. 1/2. They give us the apothem. It's 8. The perimeter, 27.7 times 3. So the area equals 332.4. Just plug that into your calculator. 91. Apothem. Area still equals 1/2 the apothem times the perimeter. You're given the apothem. That's how nice they are. Or I am, I guess. 13.9 times the perimeter. We're going to go 16. And it is a hexagon, so there's 6 sides. So we go 16 times 6. Plug that in the good old calculator. You get 61.9. I'm going to go kill my bird. Be right back. Okay, so I didn't actually kill my bird. I just fed him. Okay. So again, area equals the apothem times the perimeter divided by 2. Here, the apothem is 14. The perimeter is 11.6 times 8 because we have an octagon. Run that through your calculator. You get 649.6. Here we have another octagon. Apothem equals 1/2, or area equals 1/2 the apothem times the perimeter. The apothem is 9.2. Hey, Brea. My dog just climbed up next to me where she's definitely not supposed to be, and I'm throwing her off and definitely not petting her. So 7.7 times, I put 4. I don't know why I put 4. 7 points. Oh. This is what I was thinking was there are 8 sides, so it's an octagon, half, and so I kind of skipped over the 1/2 times 8 and did 4, but let me plug that into my calculator and make sure it's right. So 9.2 times 7.7 times 8 equals, divided by 2 equals, yeah, so I did it wrong. That's actually 283.36. Yeah. 283.36. So that's wrong. 283.36. 93, we're almost there. My daughter is so happy. Okay.
Yes. Finally.
So 94. So notice here they give us the perimeter. It equals 1/2 AP. So the perimeter equals 60. Now, they don't give us the apothem. We have to figure that out. And we're going to figure that out by using that triangle right there. That triangle has the apothem as one side, the radius as the hypotenuse, and then half a side length as that bottom leg. So what we're going to do is we need to figure out what that bottom angle is. We're going to go around, count all the sides, and we have 12 sides. So we know then that each interior angle, all 12 of them, are going to be 150 degrees. And we divide that by 2 to get 75 degrees. Why do we divide it by 2? Because we know that this angle right here, this red angle, that's going to be 150 degrees. We got that by going 12 minus 2 times 180 divided by 12. So this part right here equals 150. We then divide by 2 to get 75. Why? Because this radius right here, it bisects that angle, cuts it in half. So since we know that this top angle is 150, that big red angle one is, we know that this green one right here is half that, or 150 divided by 2, 75. So we know then that the tangent of 75 is going to equal the apothem over 2.5. How do we get 2.5? Well, we know that the perimeter is 60. See, the perimeter is 60. We know that there are 12 sides, so that means each side equals 5. Right here, see how I have 1/2 side? 1/2 of 5 is 2.5. So then the apothem equals 9.3. The area then equals 1/2 the apothem, 9.3, times 60. 279 is our answer. So, moving on to number 95. We're looking for that triangle right there. Now we know this is an equilateral triangle. How? Because it's a regular polygon. So we know that each of the interior angles equals 60, which means half of that is 30. We know that half the side, because we're given 3 miles, half of 3 is 1.5. So we got the tangent of 30 equals the apothem over 1.5. Multiply both sides by 1.5. We get 1.5 times the tangent of 30 equals the apothem. Run that through our calculator, and we get the apothem equals 0.87. I know it seems really small. I actually ran it a couple times. It's right. So the area equals 1/2 the apothem times the perimeter. The apothem is 0.87, and the perimeter is 3 times 3, or 9. Run that through a calculator, and we get the area of that triangle being 3.9. Here we have another triangle. We're told that the perimeter is 24. That means each side is 8. That means that each half side is 4. That is still a 30-degree angle. So now we're going to go the tangent of 30 equals the apothem over 4. Multiply both sides by 4. We get 4 tangent 30 equals the apothem. Apothem equals 2.3. Area 1/2 the apothem times the perimeter, 1/2. 2.3 times 24. That's our perimeter. Let's give us 27.6 is going to be our area. Now 97, our perimeter equals 5 times 6. I don't know why it's 6. I may have done this one wrong. Let me see if I catch my error. It's a decagon. So we go 10 minus 2 times 180 divided by 10 divided by 2. So we know that each of the big angles is 144. Divide that by 2. The small angle is 72. So we have the tangent of 72 equals the apothem over 2.5. That's half of 5. 2.5 times the tangent of 72 equals the apothem. The apothem is going to be 7.7. So our area equals 1/2 the apothem times the perimeter. 1/2 7.7 times, okay, got it. See, I did 50. So the area equals 192.5. Again, if this doesn't make sense to you, either come see me, rewatch the video, whatever it takes. These area of regular polygons are a significant portion of the final. It will not do to kind of skip over them. I mean, this is something we've spent the past 3 weeks going over, so make sure you know it. 98. Okay, now we could go through the apothem, the perimeter, and everything, but perimeter's 32. That means each side is 8. Find the area of a square. 8 times 8, 64 centimeters squared. Now 99, 100, and 101, these are side angle side problems. So the area of a triangle when given side angle side. So note the area of a triangle is 1/2 BC sine A. So here, the two sides are B and C, and this is angle A. So we need two sides and the included angle. So 1/2, 5 times 2, those are two sides, and the included angle, sine of 95. Those 2's cancel out, so we have 5 times the sine of 95. Now the sine of 95 is just under 1, so it actually rounds up to 5.0. So 4.98. 100. 1/2 base times height. 1/2 5 times 3. 15 divided by 2 or 7.5. Now notice this works because if you have a calculator out, hit the sine of 90. The sine of 90 is 1. So if I sit there and I go the area using 1/2 BC sine A, I get 1/2 times 5, that's one side, times 3, that's the other side, times the sine of 90, that's the included angle. Well, the sine of 90 is 1, so that gives me 1/2 times 5 times 3. Hey, check it out. It's the same thing. So 101, 1/2 times 5 times 3 times the sine of 94. Plug that into our calculator, we get 7.5 inches squared. Notice that this is basically the same thing as 100. Being that we're rounding to tenths, the difference between, it's honestly going to be a little bit higher, but because we're rounding to tenths, the difference in sine from 90 to 94 isn't all that great. Last one, 6.
Yes.
No, last one of these problems. We still have volume to do, Bugs. So 1/2. If my oldest daughter hears that I called her Bugs, she's going to kill me. That's her nickname. Me the Bug, Juka Bear, Bellaroo. 1/2 6 times 2 times the sine of 95. That gives us 6.0. And again, the sine of 95 is actually a little bit less than 1, but it rounds up to 1 when we're doing this. So that's why you get 6. So volume of any prism, base times height. We were talking about a rectangular prism. The area of the base is length times width. So we get length times width times height, being our volume. So we're going to have 5 times 12 times 9, or 540 cubic centimeters. I put square centimeters, that's wrong. Okay, volume is a cubic measurement. It's 3-dimensional. So our answers need to be in cubic centimeters. The next one is inches, so our answer is going to be in cubic inches. Now, we just did the volume of any prism, area of the base times the height. Now, the volume of any pyramid is very similar. It is the area of the base times the height, and then we divide it by 3, or multiply it by 1/3. You guys need to know, dividing by 3, multiplying by 1/3, same thing. So, 1/3 base times height, that's our volume. Now, that big B, so our height is 12. That big B means the area of the base. When we're talking about little b, like 1/2 base times height, that's the length of a side of a polygon. Talking about big B right there, capital B, we're talking about the area of the base. So here we have this hexagon, six-sided, and we need to find its area. Well, how do we find the area of a regular hexagon? We use 1/2 apothem times perimeter. The apothem we're given, that's 6.1. The perimeter, 7 times 6. Each side is 7 inches. There's 6 of them. So we get 7 times 6 to find the perimeter. Plug that into our calculator and we get 128.1 at inches squared. Now notice here we have area, so it's inches squared. We're then going to plug that back in up top, 128 inches squared times 12 inches. And there we have, notice, inches squared times inches. That's 3. So run that through our calculator. Get 512.4 cubic inches. Next up, 105, we have another prism. So, area of the base times the height. Now here, our height is the distance between those two triangles. So it's 9. The base is the triangle, so we need to find its area, 1/2 little b times h. See how that little b there is for the length of the side of the triangle? Big B is the area of the base. 1/2, 6 times 8. That's base times height on the triangle. So the area of the base is 24 square kilometers. That makes our volume, area of the base, 24 kilometers squared, times the height, 9 kilometers. 216 cubic kilometers. It's a big old triangular prism. Okay. Next up, we have a hexagonal prism. That's just fun to say. Come on, everyone with me. Hexagonal prism.
Hexagonal prism.
See, my daughter's into it. You guys need to be into it too. So, area of the base times the height. That's what that big B is, area of the base. This is a hexagon, so the area is going to be 1/2 the apothem times the perimeter. Here the apothem is 9.5. Our perimeter, 11 times 6, or 66. So the area of that base is going to be 313.5. So on my calculator, I go 9.5 times 11.6. Then I can either hit divided by 2 or times 0.5. I'm going to get the same answer. Volume then equals the area of the base, 313.5, times the height, 11, or the volume of that hexagonal prism is 3,448.5 cubic kilometers. Okay, so that's an even bigger hexagonal prism than that previous triangular prism. Okay, 2 more, 107, 108. Both of them are pyramids. I know one of them's got a circle in it. We'd call it a cone, but it's still a pyramid for the purpose of the equation. Volume, 1/3 area of the base times the height. So notice down there, the area, my base, is a rectangle. So the area of the base is just going to be 5 times 3, or 15 meters squared. The height of the pyramid, 7 meters.
Is it in Egypt?
It is not in Egypt. It's in Geometry Land.
Then why is it?
1/3, 15 times 7. It's just the shape, sweetie.
Yeah, but pyramids are made to put dead kings.
Yes.
Cats, and
It is also a shape. The shape of the pyramid is a pyramid.
no, it's a triangle.
It's a triangle. It's a 3-dimensional triangle. Anyway,
Yes, a 3D.
so 1/3 times 15 times 7, we get 35 cubic meters. Now 108, we still start off with the 1/3 area of the base times the height. The height's going to be 24 inches. And the area of our base is actually going to be pi r squared. We're given that r is 12. 12 squared is 144. So the area of the base is 144 pi inches squared. So they're going to plug that back in. We get 1/3 area of the base, 144 pi inches squared, times the height, 24 inches, gives us 1072 pi inches cubed. Yeah, I don't know what just happened. I'm going to go back really quick and run that in my calculator because I didn't even put pi in there. Not okay. So, we are going to first make sure that this is correct. 144 pi. We get 1152 pi. And look, I keep hitting next and there's nothing going on there. So 1152 pi cubic inches. It has, so we're an hour and a half in. Not too bad, I thought it was going to be longer. It has been an absolute pleasure
Hour and a half.
to teach you guys. Truly wonderful. Thank you guys for a wonderful year, and I truly, truly hope that this helps you on the final. And feel free to stop by anytime you guys want, whether you need help with math or just to say hi. I'll miss you guys. Take care, and good luck on the final.